Welcome to the AveriSource Platform 2.0 demonstration video. The AveriSource Platform enables your modernization journey through 5 unique, modular, and comprehensive products. Scan is our free premium offering designed to get you started quickly through the codebase insights and high-level risk analysis. Inventory delivers a more comprehensive view of your applications and the ability to assess completeness of your code collection. Inventory builds the analysis repository on which the other products rely and extend. Discover provides views into your application architecture and connections, dependencies, data lineage, and more. Analyze enables you to identify, isolate, and extract the valuable business rules and logic within your application and reduce technical debt. Transform enables you to re-architect your application for containerized cloud-native microservices, even on the mainframe. The AveriSource platform is powered by our parser technology, the world's most diverse parser, supporting over 70 different technology stacks throughout the AveriSource platform. We've built and evolved these capabilities over the course of 3 decades with dedicated research and development and customer projects. As a refresher, the AveriSource platform can help at any stage of your modernization planning and execution journey, and with most any modernization pattern. We can accelerate application repurchase or replacement with data migration analysis and business rule identification or extraction for using gap analysis of business functions and mapping to the selected package functionality. Analysis for legacy data replication for hybrid or cloud applications needing edge data. Daily application maintenance analysis when clients want to retain their applications. Optimization analysis when clients want to reduce technical debt in existing applications and plan for future modernization. Decommissioning legacy applications when other modernization patterns have been accomplished. And especially application reengineering or re-architecting applications for moving to containerized cloud-native microservices, what we call an accelerated rewrite. The AveriSource platform is not a line-by-line conversion, rehosting, or replatforming lift and shift solution. It is an integrated platform designed to enable application re-architecture and accelerate modernization to the platform of choice, whether that is the cloud or staying on the mainframe or midrange system. To demonstrate, I'll use a small COBOL modernization project that has CICS and batch systems with DB2 vSIM sequential files and CICS queues. For any modernization process, you begin with assessment and planning. To determine either the modernization pattern or approach, you first have to identify the content and sizing of your portfolio. We do so with scan and begin the journey of building the repository with inventory. Inventory provides missing reports and unreferenced reports to analyze and complete your analysis repository. It also provides platform utilities and third-party products for either consolidation, replacement. We have several methods that can help identify the approach for modernization. We can help you determine how connected particular entry points or jobs are, the sizing for those, or what business function mapping is necessary if you're using that approach. And then once you've determined the approach, you can identify entry points, jobs, programs, transactions using the dependencies view and the requirements for those. So let's take a look. The 2.0 dashboard provides some metrics for the code that's been parsed, some graphics to help visualize, identifies the products installed, and gives licensing information. Scan is not only a standalone product that you can run for free, it is also integrated into the platform. Even if you're doing an analyze or transform project and have additional code that's not licensed, you can, for free, parse that code to identify what license requirements might be needed. Scan provides a file analysis to show what's in it, how many, if there are missing items, how many lines of code. Also provides a risk factor assessment at a high level to provide some insight into items that you may care about for addressing for modernization. As mentioned, in the inventory, we have the missing files report that shows the items that are missing, who referenced those items, and how they're referenced if you drill down into the code. And then the platform utilities or system items to identify repurposing those functions if doing migrations or optimizing. From an approach standpoint, the Discover provides process identification. When we parse the code, we automatically index and provide generic process descriptions. This template can be downloaded, updated, and uploaded so that you can use these for grouping or various analysis functions where you map the component to a business function, like payroll. If there are no subject matter experts to identify the mapping, then you can use the clusters to give you insight on sizing or lines of code, connections, or complexity. So if I take a look at the connections and I want to look at the batch, I see custom update 2 is the largest with 72 connections. I can actually go and view those in the connections report. In any report in the platform, you can pin or hide items or columns. You can sort. You can also filter. So let's filter by the job that I just found, custom update 2. And I see all the connections related for that. There are 36 connections, so I can scroll through those and see where there are steps executed, programs executed, and what the functions of those are if they are accessing data sets or calling other programs. I can also look at the dependencies for those. If I run a dependency report, I see here's custom update 2, but also custom update T, where it maps the references from those. So I see there's overlap. So I have to make sure when I move data sets or modify data sets that I consider all of the references to those. So going through the assessment and planning, I've identified my approach. I've identified the data sets or jobs or things that I'm concerned about modifying. Now we'll move into step 2 and actually do the modernization. I'm going to do the analysis and preparation by determining the cross-reference and data access patterns for the files involved. I'm going to reduce the technical debt by elimination of cloned or dead items. And I'm going to look at the business rules to make sure they still fit the business and if they are also cloned. Then once I've eliminated the technical debt, I'm going to transform those entry points or programs and generate gateway, data, and business logic microservices. So from a technical debt standpoint, first I want to eliminate clones in my application and redundancies. As mentioned before, I can sort by column. So let's sort the similarity column. And I see that I have multiple routines named the same thing in different programs. To get in this report, the code identified has to be at least 10 lines long and have at least a 70% match to code either within the same program or across programs. Let's take a look at these. I see here that this write error message is the same routine. The only thing that's different is the text that's the message that's being sent out from the routine. So I could, in the transform, consolidate these multiple routines and create a single microservice and pass the message to it to be more efficient. We also identify dead code. These are unreferenced paragraphs. I can drill down and see the code in use and what the code is from there. From a knowledge standpoint or application understanding or onboarding, we provide the flowcharts that identifies the flow within a program. I can drill into a paragraph and see the flow within that paragraph, or even look down at the code level and identify how that is being used if I need a deeper analysis view. From a business rule perspective, we identified 12 different types of business rules. So we provide initially the metrics, the statistics for each of these. So I see that I have some very large number of rules and no actual business rules in others, but there may be different IO validations or UI facts, and the definitions of these can be provided as well. So let's look at the program custom update 2 that we were talking about from the job that we selected in our rationalization process prior. First, we see the business rule overview, which is a diagram and with percentages of the types, and then a report that shows that percentages within this program. If I look at the business rule sheet, this code is laid out in logical flow order. So you see that these numbers, line numbers, might jump around a little bit. It identifies the rule type and also some information about that. You see I have a couple of columns pinned, so I can slide over and look at additional columns and reference the original rule. So I see here I can identify business rules, and I can sort or filter by identifiers or variables, by data source, by data structure, the external source, and also see that there are hard-coded literals in some of these. This candidate rules column is important because this is the rule set. This shows the lines of code or conditions that have to be met and executed as true before you can get to this rule or condition itself. We do rule chaining, which is not just identifying the rules within a program, but what differentiates us is that we can identify rules across the job or across program call chains to identify where business rules exist in flow. We can use sequence diagrams that also help with onboarding and application understanding to show the interaction between components or IO flow in and out. Now that we've done the technical debt elimination or identification, now I can go into transform and start my preparation for generating and modeling code. The entities view creates an entity relationship diagram, which shows the one-to-many or one-to-one relationships between data sets. If I look at the details of the data set, I can see the data elements there, and I have asterisk by some. Each of these fields that have asterisk are represented on the left with the word required. What you see on the left is what we call the AveriSource descriptor language, or ADL. This is basically a text representation, a layout of that file, that entity. What the required keyword means is that this field is referenced in a business rule. We have to use that to identify when we generate the microservices, the APIs, and especially the test screens for the data framework to make sure that those fields in the test screens utilize these size constraints or ensure that the data fields are entered into the form. If I do look at the modeling view, you see the same process description from process identification before. So if you've uploaded the template and have identified this as a payroll job, then you can segregate workloads accordingly. Here's the custom update 2 job that we chose earlier. And if we view the model generated for that, I see the ERD, but now the ERD is not all of the entities in the project as before, but only the ones referenced by this job or entry point or program. There are 3 sections to the AveriSource descriptor language. One is the configuration section to tell what type of microservices are being generated, and what the data sources would be, how to build them, what the UX would be, if any, and then possible testing tools in those. So there will be a data microservice or a microservice generated for each data entity and business logic component, as well as the entity section has the description that we just described. And then the business logic section is commented, and this will be passed through the forward engineering process. And you see it has the legacy language logic for the paragraph or the methods there. And this can help business analysts or the Java developers, the development team, to see what the code was before, and then also the generated code to replicate that functionality. And as you see in the Java code, there are no proprietary runtimes. We generate structured, maintainable, object-oriented Java or C# with no proprietary runtimes, platform, or vendor locking. From the screens view, we look at renderings of the 3270 screens or 5250 screens, the green screens, and see the locations and the usage of the fields and the labels. Developers can download this HTML rendering and the Angular projects to begin their UX work. So what we've done is we've gone through now and eliminated our business logic, verified the business rules, and generated code to test. Now we need to go into the data framework and API testing. We can build the code that was generated, build the databases. We create YAML files for those configurations, and we also generate test data, fake test data, to populate into the databases so that you can immediately test that data framework. We provide a local free register for a registry for the microservices. So we can register and start those microservices, and we've already loaded the data. I can use the SQL Server Management Studio to see that, and I'll show. Also, we want to test that data framework. We want to see those microservices and the APIs and the auto-generated user interface screens. What we designed is what we expect. But let's do that. This is the free registry, and it shows here where I have registered each of these microservices within that entry point that we used. These are all of the entities from that microservice or from that entry point that were generated. These are the data microservices. So I can go look at that credit loan account file that we were talking about. You see it has all this fake data populated in it. If I pick one that's a little easier to view, I can actually edit this data, this fake data that was populated, and you see the entry screens designed. Here, if I key data into this field, you see it says it cannot be longer than 8 characters. So that's where those sizing constraints come in. If I want to add a new record to this, then I can go and tab past this field, and you see it says the field is required. So this is one of those items that was identified as referenced in a business rule. There are also the APIs generated. We have the main micro gateway microservices, the business logic microservices, and the data microservices generated. And these are the APIs, and I've done no UX work here. So I can pick credit loan account files, microservice get with an ID, so that I can key in a number here and hit execute, and see that fake data that was populated previously. If I go and look at the fake data, it's just text data that was generated, but it maps to the structure. Let's take a look at one of the YAML files that was generated. This is for the custom update 2 microservice, the logical program. And we have to, into the YAML file, we have to add the registry location. For that test that we just ran, we have to have the database connection string. And here's the command where we generated the data. If I look in the SQL Server Studio, I ran a query, and you can see where this fake data is populated in the database that we just queried. So we've gone through and tested those. Now we're ready to make assignments to our team. Previously, this has been the enterprise or the modernization or the data architect going through the process of design and creating the flow. Now I have those rendered Angular projects, and I can have the UX team work in those generated Angular projects, finish the business logic microservices, the development team, and have the appropriate infrastructure folks build the landing zones, or depending on where you're going, implement security, migrate data, test, and promote. So I've gone through the entire process within the AveriSource platform to get ready for that. I've generated up to 95% of the code to accelerate the process, create a structured framework that my developers work within to improve code quality, and tested that framework to make sure that the process is ready to begin. Transform has many features right out of the box for integration with Maven or Gradle, for instance, the configuration files for SonarQube or Prometheus monitoring. And then it works with many different databases and products. But the key points to identify on the right, which from a Java perspective, we use the Spring Boot framework. From the C# perspective, we're generating .NET Core, the Angular projects or industry standards. But the key components here, as I mentioned, that we generate structured, maintainable, object-oriented Java or C# code with no proprietary runtimes, no platform or vendor lock-in. To implement the platform within your environment, these are the hardware and software requirements, which our customer success team provides at the beginning of your project. And these are the transform requirements, and items 4 through 6 are included in the transform package. If you're implementing within the cloud, AWS for instance, then we can provide implementation architectures. And then depending on where you are deploying the code generated, we don't recommend products or platforms necessarily, but we partner with all of the cloud and mainframe providers. So we provide reference architectures, templates for deployment to AWS, Azure, Google, IBM, including back to the mainframe in Red Hat OpenShift on Linux or Linux One, Oracle Cloud. And even if you're deploying into your distributed data center, then we have the architecture and some popular products. But don't take our word for it. Read our testimonials from our website. Sign up for our blog and start your modernization journey today with free AveriSource Scan. For more information or a personal demo, contact sales at AveriSource.